Well, the purpose of this video is to just kind of walk you through each of these parts of the worksheets, and probably the first video will be the first side and the other video will be the next side. But I wanted to help you understand better. Hopefully after this you'll be solid with these concepts, being able to do everything for problems 1, 2, and 3. So let's go ahead and get started. First course of business is to figure out when the particle is moving to the left, and I'm going to start using red, and well, at least I'll do that in this video. Red representing to the left. And as we talked about in class, we know to the left is when the position slope is negative. So if you check your chart, the position slope being negative would be right there. So the particle, if you look at the graph here, this is the graph of the position, and I just want to make sure we point that out. Let's do position here, right there. Anyway, when the position graph has a negative slope, which is what we see there, we see that that happens from t equals 2 to t equals 4. So that's just when the slope of the position is negative. That means that the velocity is negative. So s prime is equal to the velocity. We can think about it like that as well. And then the other part is, when is it moving to the right? Well, it's moving to the right when the slope s prime is positive. And that's, again, the velocity being positive. And the velocity being positive is right there. You can see, hopefully you can see the highlighted area there. The highlighted in green means that the s prime, the slope of this line, or that line segment right there, is positive. And that occurs between the values t equaling 4. So from t equals 4 seconds to t equals 6 seconds. And when is the particle standing still? Well, I don't have a highlighted for that, but the particle is standing still. Let me actually get this here. What would be a good color? How about purple? So standing still right there where the s, standing still when the s prime would be equal to 0. In other words, the derivative of the position, or the position isn't changing. Okay, so if the position isn't changing, then the particle is standing still, and that occurs between 0, let me zoom way in here, between 0 and, what is that, 2, t equals 0 to 2, and then also, can I squeeze that in here? Let me put it down here, and also from t equals 6 to t equals 7. So from time 6 to 7 and from time 0 to 2, the particle is standing still. So we actually graph this in class, and the particle's velocity and speed anyway. We graph the velocity, meaning the slope of the tangent line to the, or slope of the curve, s of t. Sorry, I had a little thought there that just went awry. Anyway, we saw that the slopes right there where I circled, in fact, let me circle that other part there. Anywhere here, the slope is equal to 0, and same with right here. Let me just draw an arrow there. Oops. So the slope right down here is equal to 0, and right there. So when the slope is equal to 0, between 0 and 2, that means that, oops, didn't mean to do that. I meant to go all the way here to 2, and open circle there on 2. That didn't look that great. Let's do an open circle. Looks better like that. That means the slope of the tangent line to this graph of s of t is equal to 0. Well, we also said that the slope here, everywhere on this curve between t equals 2 and t equals 4, we said that the slope was equal to negative 4. And if the slope is equal to negative 4, that means that the derivative of the s prime is equal to negative 4. And, well, guess what? The slopes of s are the same as the velocity. So the velocity, that's the slope of s of t. Okay, so that's really what we're graphing, is we're providing a picture of all the slopes of the graph of s of t. Okay, well, then down here in between the t values of 4 and 6, well, we said that the slope was 1. And if the slope is 1 there between t equals 4 and t equals 6, then, well, we indicate that right here on the graph of the velocity. The picture of the slopes here would be picture of would be 1 right there. So the value of the velocity is the value of the slope of s, which is equal to 1. And then finally, we also mentioned that the slopes between t equals 6 and t equals 7 are equal to 0. All right, well, that's fine. That's the slope of the s of t. Well, then once we get the graph of the velocity, then we can graph the speed. And the speed, again, is the absolute value of the velocity. And so everywhere where the velocity is equal to 0, the speed is equal to 0. So we have from 0 to 2, we have from 6 to 7, and so those don't change. Then what we have is the graph of, or where the slopes are positive. In other words, when velocity is positive, and that's between t equals 4 and t equals 6, the slope is 1, or the velocity, I should say, is 1. And then, but then the only part that changes is right down here where the velocity is negative. Okay, so you see I highlighted where the velocity is negative. Well, when the velocity is negative, the absolute value of the velocity then is going to be positive. So that's the only thing that changes between the graph of the velocity and the graph of the speed. Okay, well anyway, if the velocity is negative 4, the speed is positive 4. So there you have it. That's, well, okay, the graph of the speed, and then actually down here in the bottom, when is the particle moving the fastest? Well, when it's got, again, the translating part, that's when the speed is greatest. Okay, so that's how we translate that. So greatest. So when the speed is greatest, we can see that clearly is right there, and I'll circle it even, clearly right there between t equals 2 and t equals 4. So hopefully that gives you a good solid understanding of that particular problem. And I don't know if you can see all the movement of that or not, but we'll see. I'm just talking to myself right here. But anyway, we'll pick up the second page here, the back side of this worksheet, in the next video.